Hi everyone, today we're talking about scatterplots, correlation, and regression lines. Scatterplots are just collections of XY data points. So for example, if you have a table of inputs and outputs, or X's and Y's, we call X the independent variable and Y the dependent variable. To plot these, I'll go over to my X value on the X-axis and then up to the Y value on my Y-axis. So let's say I've got the points 2, 1, 3, 3, 4, 5, and 5, 7. And then I stop here. So a scatter plot is a plot of just the points, just the XY coordinate points. Correlation measures how closely any two related data sets are, or how closely related two data sets are. So if I've got this set of points X and this set of points Y, their correlation is going to tell me how closely related they are. So first, just thinking about the scatter plots, if we have points that seem to be following a trend in some direction, we would say there's some correlation. If everything's just like spread out like stars in the night sky, we would say there's no correlation. And if things line up perfectly in a line going up or down, we would say there's a perfect correlation. We can quantify this notion of correlation with the correlation coefficient that we call R. So R is a number that's always between -1 and +1. 0 means there is no correlation at all. If the variables have a positive correlation, R is in between 0 and 1. And if the variables have a negative correlation, R is in between -1 and 0. So the positive or the negative just tells us the direction of the slope of the relationship between the two data sets. And then the magnitude or the absolute value of R tells us how strong the correlation is. So for example, let's draw some scatter plots with these particular R's. So if R equals 1, +1, that's perfect positive correlation. So they would be in a straight line, perfectly linear, and increasing with a positive slope. If R is 0, there's no correlation at all. So this is the stars in the night sky. No correlation. R is 0. No relationship. If this one R is about 0.6, I'm saying about because I'm just freehanding a sketch here. It's positive, so it's increasing. And we can see a trend through the points, but they're not all on the exact same line, but they're getting pretty close together. -1 would be perfect negative correlation. -0.8 would be strong negative correlation. And then -0.2 would be weaker negative correlation. So this is weak negative, strong negative, and perfect negative. correlations. So the closer the absolute value of R, your correlation coefficient, is to 1, the stronger the correlation between the variables. So negative 0.8 is a stronger correlation than negative 0.2. So if we have two data sets, we can calculate this correlation coefficient. We can do it by hand, or we can do it in a calculator. First, we're going to talk about how to do it by hand. So let's say we have two data sets. I'm going to call them capital X and capital Y. All my X's, all my Y's. X sub 1 through X sub n, Y sub 1 through Y sub n. So notice there's the same number of points in these. If each data point is xi, yi, so like x1, y1, x2, y2, the correlation coefficient we find with this big scary formula, it's going to be n times the sum of x1 times y1 minus the sum of x times the sum of y's over these two square root expressions. So the square root of n times the sum of the xi's squared minus the sum of the xi's quantity squared, and then similarly for the y's. So n, the number of data points, times the sum of all the y values squared minus the sum of all the y values quantity squared. So all of these little sigma summations are summing from I equals 1 to n, all of your data points. So to use this formula, let's look at an example to see what happens. So let's say we've got two data sets that we're interested in. X is going to tell us the percent of citizens in a country that are literate. Y's tell us the percent of citizens in a country who are malnourished. And so let's look at 1, 2, 3, 4, 5, 6, 7. Our n equals 7. So for example, in Cuba, 100% of the citizens are illiterate. That's impressive. Only 2% are malnourished. In Ethiopia, 36% of the citizens are literate. 46% of the citizens are malnourished. So we might suspect a correlation here. As literacy goes up, malnourishment goes down. So we can calculate the correlation coefficient to see if that is true, how closely related these two data sets really are. So the way I would recommend doing this is setting up a table here. So I've got my x values and my y values. What I want to do is find all of their products, x times y, and then x squareds and y squareds, because I need all of these sums in my formula for R. So let's go through these. 100 times 2 is 200. 100 squared has 4 zeros. 1, 0, 0, 0, 0, and 2 squared is 4. So I'm going to multiply x and y together in this column, square my x in this column, square my y in this column. I'll work through these. If you have a calculator, you can do this with me. 71 times 4, 284, 71 squared, 50, 41, 4 squared is 16, 36 times 46, 1656, 36 squared, 1296, 46 squared, 2116. So you see how tedious this is. To do by hand, but it's good to know where all these numbers come from. So once I've filled in my columns, the products of the x and the y's, all the x's squared and all the y's squared, I want to sum each of these columns up. So I'm going to add all my x's together to get my sum for my x's. 100 plus 71 plus 36 plus 98 plus 50 plus 99 plus 67. 521. I'm going to sum up all the other columns now. Four, 2, 7, 3, 1. Now summing up my y squareds. 4 plus 16 plus 2116 plus 4 plus 576 plus 9 plus 361. It's 3068. So now I can plug everything into my equation for r. I'll put the equation right here, and then all our sums that we found from our table here. So r is n, which is 7, times the sum of all the x times y's, so 5106, minus the sum of x times the sum of y's, so 521 times 100, divided by the square root of n, which is 7, times the sum of the x's squared, 42731, minus the sum of x's squared, so 521 quantity squared, and then the same thing times the square root of the y's, 7 times the sum of y's squared, 3068, minus the sum of the y's, 100, quantity squared. Now when I put all this into my calculator, let's do it in kind of baby steps. 7 times 5106 minus 521 times 100. Negative 16358 in the numerator, over 7 times 42731 minus 521 squared. Now take the square root of that, 166.36. Then 7 times 3068 minus 100 squared. The square root of that, 107.13. Negative 16358 divided by 166.36 times 107.13. Negative 0.9178. And so I rounded kind of in the middle there. But the r that I end up with is negative 0.9. So this is a strong negative correlation between these variables.